Hello everyone, wherever you are. Thank you very much for joining us today for the Innovation for Cool Earth Forum 10th Annual Meeting, hosted by the Ministry of Economy, Trade and Industry, and the New Energy and Industrial Technology Development Organization. Now let us begin the side event program, NEDO Green Innovation Fund Project Symposium, Carbon Neutral City Achieved by Next Generation Photovoltaic. To start the session, Mr. ANZAI Kazutaka, Deputy Director of New and Renewable Energy Division of Agency for Neutral Resources and Energy, will give an opening remark. Mr. ANZAI, if you please.
Thank you for your introduction. Thank you. I'm ANZAI Kazutaka, Deputy Director of the New and Renewable Energy Division of the Agency for Natural Resources and Energy. It's a great pleasure to have this opportunity to deliver the opening remarks at this session. I would like to thank you, everyone, at the venue and online for your participation. I would also like to express my appreciation for the effort of all those concerned, beginning with the member of the steering committee. Countries around the world are promoting a large-scale introduction of renewable energy in order to achieve carbon neutrality. Japan is also expanding the introduction of the renewable to achieve its new greenhouse gas reduction targets in 2030, with the aim of realizing carbon neutrality in 2050. Among the various types of the renewable energy, the amount of the solar power installed worldwide in 2022 significantly exceed 200 gigawatts, making a record high. Currently, silicon-based photovoltaics are the mainstream, but perovskite is attracting attention as a new next generation photovoltaic technology because it is the lightweight, flexible, and highly efficient. The government of Japan will expand its scale of the support through the Green Innovation Fund project to establish mass production technology for perovskite photovoltaics, and it's also requiring a budget for the GX supply chain construction support project to support mass production of perovskite photovoltaics toward early popularization and expansion. The government with support to establish mass production technology, create demand, and develop a production system for perovskite photovoltaics to realize social implementation even before the year 2030. I would like to conclude my remarks by expressing my hope that this session will lead to further exchange and cooperation through the exchange of information of technologies, initiatives, and policies related to next generation photovoltaics such as perovskite. Gracias.
Thank you, Mr. ANZAI. Now I would like to introduce the session organizer, Mr. Kiba of NEDO. Mr. Kiba, if you please.
Thank you for your introduction. First, I would like to express my appreciation to all the panelists and the audience attending this session. Large-scale introduction of renewables is underway around the world with the aim of achieving carbon neutrality. One issue in such effort in carbon neutrality is urban areas where renewable energy installation locations are limited. One promising solution is practical application of lightweight, flexible, highly efficient next-generation photovoltaics that can be installed on house and building roofs with load constraint and on unused walls and windows. Perovskite photovoltaics are expected to be next-generation photovoltaics that meet these conditions. After the first report of the perovskite solar cell was published in 2009, the record for cell size conversion efficiencies surpassed 25% in the research stage. Perovskite modules are also significantly lighter than other types of and can even be fabricated on flexible lightweight substrates. Okay, next slide. Next slide show, please. Excuse me. Next slide, please. Sorry. Therefore, at this event, we invited 6 experts to give an overview of R&D and demonstrations of perovskite photovoltaics in Japan's Green Innovation Fund project, as well as their potential market needs, and to discuss implementation methods mainly targeting urban areas. The scheduled time of this session is 1 hour and 45 minutes. In the first half of the session, the moderator and the other panelists will give presentations as described in this program. After the presentation, there will be a panel discussion and Q&A for 35 minutes. We will also accept questions from audiences. Online participants can post questions through the YouTube. Thank you very much.
Thank you, Mr. Kiba. Next, I would like to introduce Professor Takamura Yukari of the Institute for Future Initiatives of the University of Tokyo. Professor Takamura is also the keynote speaker and the moderator of the session. Professor Takamura, if you please.
Thank you. Good morning and good afternoon and good evening according to where you are. So it's a great honor to have opportunity to deliver a keynote speech, and thank you very much for thank the co-organizers and the Ministry of the Economy and the Industry and Trade and the Industry and the NEDO to give me such a wonderful opportunity. So could you, thank you. So I like to start with the, yes. Now, as you know, that the international community go toward the climate neutrality, carbon neutrality. So in 2015, the Paris Agreement agreed, and which stipulate 2 temperature-related goals, as you know, that well below 2 degrees Celsius below pre-industrial level, and also 1.5 degree goal, or to be achieved with best effort. So Japan already announced the carbon neutrality by 2050, together with the other countries, including all emerging and countries. Also, do you know that in COP26 held in the UK, it is the COP26 the climate negotiation meeting. More than 190 countries agree to achieve pursue their effort to achieve the 1.5 degree. So it is already confirmed by the G7 head of states and also G20 head of states. The background of such kind of very ambitious target is the feeling, the climate threat. As you know, even this year, we have a very severe heat wave, which caused, forest fires and also the flooding. And also the climate science, they show us that that will be become more severe. Oh, I'm sorry. Yes, the climate science project that such kind of climate change will more frequent and more intensified. So the most recent science shown by the IPCC, the sixth assessment report, we have to really reduce our emission with such a scale and with a very much speedy pace. So for instance, in 2030, compared to the current emission level, globally we need the 43% of emission reduction to achieve the 1.5 degree with the more than 50% of probability. And looking at the CO2 basis, by 2050, we have to be the almost carbon neutrality in 2050. So this need clearly the system transition. Especially, here in the topic focus on the, next generation PV, and looking at what type of, what kind of speed of the energy transition, especially in the power sector, needed. So here it's come from the International Energy Agency NEDO scenario, not the most recent one, but it is published in 2022. By 2025, globally nearly half of electricity comes from the low carbon sources. And by 2035, the developed countries' power sector should be largely or completely decarbonized or come from the last, you can see with the blue, blue one, I'm sorry for that, by 2050, nearly 90% of power come from the renewable sources. So the good news, as the Mr. Ando from METI already mentioned, that we have now the cost-effective mitigation option. Among them, the solar and the wind is have the most potential, has the most potential mitigation option. And currently, under the expansion of the new power generation of new renewable capacity, the expanded, and again, also the investment as well. Unfortunately, we have not yet, have a plateau of the global emission, but still, in terms of the 2022, excuse me, the solar and the wind expansion actually offset the increase of emission of power sector almost. So that is, I think, really the promising situation toward the decarbonization of power sector. But still going to achieve, in order to achieve the net zero by 2050, the most recent IEA report about the net zero scenario, that we need triple the renewable capacity by 2030, and beyond 2030 and furthermore. So that is, especially the solar have a very critical role to achieve such kind of ambitious target in terms of renewable capacity and the power generation from the renewable sources. So I understand that perovskite solar cell have quite, the good progress of, especially in terms of efficiency, and also the possibility of much broader application, for instance, in urban area, that where the large-scale deployment of conventional cells could be difficult. So especially cities is a source of, I think more than 60% or 70% of global emission, account for the city's activities. So that the perovskite and the next generation PV cell have a critical role to achieve the zero or the decarbonization society by 2050. Of course, the challenge exists. I'm not going in detail since the panelists are, expert. Definitely will go into more detail. So the last, not least, excuse me. Doesn't. Excuse me, I think, yes. The last, not least, I wish to finish my speech with the expectation and the challenges of the new generation PV. As I said, that the greater role is expected in emerging new energy systems toward decarbonization. In order to make this situation a reality or scenario a reality, we need technological innovation, of course, but also the institutional innovation, supported by the policy and measures. So here I just cited the create, the fast and the early demand for the new technologies such as the new generation PV and also create a market. And of course, for new technology, we need some institutional arrangement, especially the standard and quality control and the regulatory framework. Infrastructure is also necessary. So to the end, I think to make this, the expansion of renewable and toward the decarbonization, we definitely need a collaboration with a variety of technology areas, disciplines, including the chemistry, chemical industry, and the energy sector industry, and the architecture, construction companies. I think this panel, the after speech, that will cover this kind of collaboration. So thank you very much for your attention. Thank you.
Thank you, Professor Takamura. Now we will move on to the next, Mr. Yamazaki Mitsuhiro, Director, New Energy Technology Department, NEDO. Mr. Yamazaki, if you please.
Good afternoon. I'm Mitsuhiro Yamazaki from New Energy Technology Department of NEDO. Thank you for inviting this forum. I would like to show about short brief of Green Innovation Fund project of perovskite. Japanese government has declared in October 2020 achieving carbon neutrality by 2050. The Ministry of Economy, Trade and Industry, METI, has set carbon neutral green growth strategy, this 14 growth sector, such kind of offshore wind, photovoltaic, hydrogen, and other area. Then after 2 trillion Japanese yen, about equivalent, about 13 billion US dollars funded has been established in NEDO in March 2021. to launch project, the big project, Green Innovation Fund project. This project has 3 pillars, continuous support for up to 10 years. And second is ambitious R&D target to social implementation. Third is this project, mainly conducted by company, has set management commitment. This project also budget have been added this year. This is 19 project. Besides perovskite solar cell, so such kind of other project is offshore wind, hydrogen, green steel, carbon recycle, CO2 separation, and this project. Now, 90 project. So this project operated by NEDO, cooperated with METI. Move to talk about perovskite. So currently, in the world, photovoltaics is very popular. 1.1 terawatt have been already installed. In Japan, so many solar power generation have been already installed by FIT scheme by METI. This right shows. Japan has a very big solar power generation amount, so very limited land area. So for future, East Asia and Southeast Asia is very populated area. Is little difficult. So for the installed conventional solar photovoltaics, further expansion, solar power generation installation will be difficult. So one of the solutions is this kind of lightweight, flexible, high efficiency next generation photovoltaics. The left slide, IEA shows this rooftop and building sector is huge amount of installation of photovoltaics. The perovskite is expected to one of the key solution because significantly light other than conventional photovoltaics. And it might be, it will be easily installed urban area. In this project in Green Innovation Fund, so we developed R&D, so focus on the perovskite project. So we conduct R&D, so focus on the such kind of high efficiency, large size module, and durability, reliability. And we aim the social implementation, the perovskite photovoltaics by 2030. So we have 3 stages. One is laboratory R&D. Second is upscale. And third, demonstration project. So now conduct tema 1 and 2. One is basic technology, mainly conducted by AIST. So second is application project, so conducted by 5 companies, Sekisui Chemical, Kaneka Corporation, Toshiba, Eneco Technology is spin-out venture by Kyoto University and Aisin Corporation. The 5 companies in the project is a different type of perovskite photovoltaic module. So NEDO support for this project. Then after Sekisui Chemical and Kaneka Corporation, so their speaker will be detailed, will introduce detail. So thank you so much. NEDO also conduct Beside perovskite project, we have conducted the broad area of photovoltaic R&D. Thank you so much.
Thank you, Mr. Yamazaki. We will move on to the next, Dr. BESSHO Takeru, Section Manager, PV Group, R&D Center Corporate, Sekisui Chemical Company Limited. Dr. BESSHO, if you please.
Thank you very much. Very nice introduction, very kind. So my name is Takeru BESSHO from Sekisui Chemical Company, and we'll talk about our R&D of perovskite devices solar cells. So thank you very much to have this kind of a good opportunity. So first, I want to talk about the acknowledgement. So we have a collaboration. So as Yamazaki-san introduced our activity with collaborated with METI, Keisansho, and NEDO, and also several universities, and also institute in Japan. So especially we have a collaboration with the University of Tokyo. Actually, I was in there. And after that, we have a collaboration with the Kyoto University, and also private university of Ritsumeikan University. And we have several professors collaboration together about the R&D system. And then we also have a collaboration with ICEF, so National Institute of in Japan, and with Dr. Takeru Murakami, who knows about perovskite devices very much. And first publication of perovskite devices in science, his name is on that. So we have like a very good specialty collaboration about perovskite solar cells. And then, so I want to talk about like a basic science of a Sekisui chemical company. So we are chemical companies, and we have like knowledge about chemistry, especially. And the companies has like 28 technical platforms, and this is related and utilized in our companies. And especially, we are thinking about the sealing technology and the process technology and the material technology and deposition technologies to put the system and also structure of our perovskite devices. So as you can see, right-hand side pictures, this is a cross-section image, just image of a perovskite solar cell. And our active layer is a perovskite, and which is like printed by a roll-to-roll process. And then it is sandwiched by a backsheet and a barrier film, and with a sealing resin. And we have like this kind of like a vacuum deposition process and resin design material technologies and the precision coating technology we have developed by ourselves. So in our like systems, so we are concentrated on the roll-to-roll system for the fabrication of perovskite devices. Now we are concentrated on the settlement of the 300 millimeter width. And as you can see, upper left-hand side, this is our roll-to-roll process, and the black part is perovskite materials actually. And the roll-to-roll process is very like a standard process in our Sekisui chemical companies, because we are handling a film a lot actually. And then we have transported the technology to application of device fabrication of perovskite coating. And then now we could make so downside and left-hand side and the devices 30 square centimeter and like 1 square centimeter, 1 meter square devices, and compliant with IEC 61215, and this is like a solar cell standard like test, and for major derivative test, it is decided by the rule. And finally, we have achieved the power conversion efficiency of 15% in our roll-to-roll based perovskite devices. So now we are on like a film devices. So the characteristic and flexible and lightweight and easier installable of our device fabrication. So this is like an example of our devices. So it's very light and very bendable, flexible, And we can make this kind of a device very easy fabrication process and low cost. So now maybe people are thinking about like a very good technology of a silicon based photovoltaic systems already. But actually, silicon is very great, and the solar cell is really like a very nice, efficient. And silicon solar cell already could be shown like 20%, and also more than like 20 years durability test, and it's really stable. And now our perovskite solar cell in the Sekisui chemical company. So current efficiency of 30 square centimeter is a power convergency of 15%, and the durability is just 10 years. So this is not enough for the market. So now we are thinking about the development of 20% of power convergency in the future, and as soon as possible, and more than 20 years of durability together with a high efficiency. And now we could make like 1 meter and like a 2 square meter modules by roll-to-roll process. It's possible, and it's very light process. And so contribution to the domestic industry, actually the dependency of a silicon source at overseas. And in Japan, it's not easy to get like a silicon good source, and in Japan. So we need to import from overseas. But compared to this situation in silicon solar cell, for the perovskite solar cell, so stable supply of materials in Japan is fixed actually. And perovskite key materials is from iodine and also lead, PB. And actually 30% of iodine production in the world is from Japan, fortunately. And this is a cheap and a stable supply of the lead. It's very easy to get it. And actually we are making an effort to lead a free system as well. But so second, so anticipation to not only domestic industry market, but also abroad by low-cost materials from Japan technology. So we don't need to worry about the materials itself for perovskite devices. And we are also thinking about the life cycle assessment, low-cost LCA, and first, low LCA by easy mass production, so roll-to-roll process in our chemical, Sekisui chemical company. So this is very easy and low cost, and saving resource of materials by less than the thickness of actually perovskite activities is less than 0.6 micron thickness, so very thin, 600 nanometers, and we can save the material itself. And this is a very important point that our perovskite solar cell is very light, so 2 to 3 kilograms per square, and flexible and very light. So easy. We are thinking about the easy installation to human life and the city and any places. So our target for the power generation cost, actually this is a target of NEDO as well, and 20 yen. Like 4 per kilowatt hour, but we are thinking about more than less than 20 yen. So our final target is 14 yen per watt. This is our target in the future. So we are thinking about low load capacity. So normally a silicon solar cell shows like a little bit like a higher heavy load capacity, like a 20 kilogram per square and 10 kilogram per square, with a very good efficiency and a high durability. But our target, our perovskite solar cells can reach very low load capacity, like less than 3 kilogram per square, and low cost in the future. So the center picture shows that like 3 devices over 2 square meter wide over our perovskite devices already, and we showed this kind of a demonstration in G7 activities. And now we are thinking about application to the building. This is a picture of the NEDO building, and also like airport harbor and railway as well, and also bus shelter and highway or roadway, and like a very light rooftop, something like that, and which is not the market of silicon devices. So we accumulated the market size of silicon solar cells now in Japan is about almost like 70 gigawatt. And then potential market size of perovskite solar cell in Japan, we expected like 1.5 to 2 times rather than silicon devices. And after that, expected the potential market size of a perovskite device in the world is more than in Japan, over 10 times larger than that. So the potential of company, so our Sekisui chemical company is not so small, and we have like many possibility on the persons. So we believe that we can manage by ourselves for the supplement of perovskite devices by ourselves. Yes. So now Sekisui chemical company want to get like sustainable society from sustainable materials to sustainable energy by perovskite devices, our technology. Thank you very much.
Thank you, Dr. BESSHO. We will move on to the next. Dr. Yamamoto Kenji, Senior Officer, General Manager, Photovoltaic and Thin Film Device Research Laboratories, Kaneka Corporation. Dr. Yamamoto, if you please.
Thank you for a nice introduction. It is a great honor for me to have a presentation here. I'm going to talk about the R&D of high-efficiency perovskite module and its application to Japanese residential and building market towards carbon neutrality. My name is Kenji Yamamoto from Kaneka Corporation. This is an outline of my today's talk. First of all, I'd like to talk about the Kaneka research and business activity on PV, and then move to the high-efficiency perovskite module, over 20%, and large area see-through perovskite module, manufacturing process, and also, but still this is mock-up, and also together application of bifacial perovskite module, mini module to tandem solar cells. It shows over 30% conversion efficiency. And then I'll discuss about the cost impact, especially efficiency. And then, and summary, we are now working on that residential and urban application, residential application, and building integrated PV. But this is still silicon. And then some part will be moved to the perovskite-based PV. This is a present business of Kaneka. We are working on a special, We are working on a roof tile integrated photovoltaics module. We call our product name is BESSHO, small and roof tile. It works not only the PV, but also the roof tile. And also see-through also module by silicon. And also recently we have started the PV roof for automotive. Integrated one. We put our heterojunction IBC cell on curved roof. This is our history and research and business. We had been manufacturing the thin silicon. The perovskite is anyway film. Thin film device, thin film module. At that time, we made it 1.4 by 1.1 meter, square meter, and then switched to the silicon. The main reason is the efficiency of thin film silicon is not good enough. And then we showed a world record efficiency of 26.7% of that our silicon cell. Over 5 years, we had a holder, but unfortunately, almost 1 year, we are 26.8% replaced by only 0.1% increase by Chinese company. And together, we also have a world record holder of that module. But unfortunately, also 3 months ago, was also replaced by the US SunPower. Now we are working on a perovskite based upon technology of that thin film silicon. And also business is, as I explained, and we are very focused on roof tile integrated type and also the building integration, and also automotive. And the cell and module itself, Kaneka make cell by Kaneka. This is our mini module result, and the standard type we have showed over 22.2%, and the series interconnected, glass front electrode, P layer, I layer of perovskite, and layered rear electrode. Now we are very much focused on a bifacial type. Also showed that 20.8%. This measurement also performed by the AIST, confirmed measurement, but for the measurement itself, we cannot take into account the light rear side, from the right rear side. So in real situation, of course, depends on the situation to situation, usually up to 2 to 3% higher energy output is expected. So it depends on the installation situation, but usually bifacial 20.8 is higher than that of 22.2 in energy point of view. Then I will show you the manufacturing scheme of our perovskite. Formerly, we developed that we had been manufacturing the single silicon. Okay, that is usually the tissue patterning, and in the case of single silicon, CVD, and now that we are working on a wet coating process of perovskite, and then the same process is going on P2 and rear electrode and P3 of that series accomplished series interconnection, and then wiring, lamination, and IB measurement. And see-through case is sometimes we remove the active layer by see-through laser patterning. This process is a very robust process, and moreover, this is a fully integrated process. Okay, namely, once input the glass, we get the product, module product, which has already measured, and also lamination and wiring, fully integrated process. This is very important. And usually one factory, only 2 to 3 hours, we accomplish everything, completely different from the silicon. And then one of the application, we have not decided the mother glass, size of the mother glass. For example, once we applied 1.2 by 1.0, we divided, cut it, and then we can make a whole perovskite solar cells for roof tile integration. This is automatically performed, okay? Fully integrated process. This is an example of the see-through module. Probably you can see my face. Okay. So, for making a see-through module, this is original yellow is original one, and then we remove the 30% and the opening, and then this is a case of 1.2 by 1.0 mock-up of the see-through. You can see that from the this is bifacial, and from the front side to rear side, you can see that background of the picture. Okay, we can also by laser scribing we can change that opening and 10 to 80 or 90, and then we also at the same time we can like gradation like this. This is thin film silicon, thin film technology, and then also this our perovskite is bifacial. We can apply that bifacial module to the combined silicon. This is one of the example. We show that once we apply the top cell efficiency of 19.5, we show that over 30% of this size. Actually, this time we used very high efficiency of bottom cell, 26.2. Once we use a standard cell, we still get a higher, efficiency improvement, like 8%. This case is only 4.6%, but usually 6, 7, 8% is performed by applying the bifacial perovskite on silicon. And then now take a look at the cost impact, okay? For us, most important cost is yen per kilowatt hour. Of course, we call the levelized cost of electricity. And now, okay, focus on the system cost, okay? System cost is, this is the literature is kind of the METI procurement of the price calculation early this year, published. Okay, here, half of the module, half of them. So any other is construction and mounting and power conditioner. So increase the module efficiency is really important. So then construction, mounting, PV module cost also reduce. So at the same time, system cost reduce. Same time, LCOE reduce. Yen per kilowatt hour is reduced. And also, panel cost itself is material like manufacturing equipment, what we call the CapEx, and also labor and utility, and so we call it OpEx. In the end, material cost is really key. Material is not only the perovskite itself, but also several. Okay, I have to finish. And anyway, in any case, module efficiency is important with volume and very high yield. And this is an example of that our perovskite tandem, perovskite and crystal silicon tandem mockup. And a little talk about that. This is a case of the roof tile integration of an urban house. And take a very quickly look at our see-through type and solid type is used, and higher level, we are going to apply that very high transparency of see-through. Lower level, just put on, a solid one. This is one of the example of that. This is a courtesy of Taisei Corporation. I just want to show you that Taisei Yokohama, this is a renewal. Okay, now this is, we call the solid type, and as a spandrel, and the see-through type is a window, not all of them. And the total power is 72 kilowatt is expected. Thank you very much.
Thank you, Dr. Yamamoto. We will move on to the next, Professor Dr. Francesco Frontini, Head of Building System Sector Department for Environment, Construction, and Design, University of Applied Sciences and Arts of Southern Switzerland. Today, he is joining virtually. Dr. Frontini, if you please.
Hello, good afternoon, everyone. So are you going to launch the registration of the presentation? Okay, good. So good morning, good afternoon, everyone. Sorry for this technical issue. I was expecting that since the representation is recorded, you have launched the representation. So my name is Francesco Frontini, and I would like to thank you, NEDO, especially for the organization and their invitation to attend this panel discussion on perovskite for BIPV. I'm leading a research sector at SUPSI in Switzerland, and I'm also co-managing the IEA PDPS Task 15 dealing with photovoltaic in buildings. Can you go to the next? So few seconds on SUPSI. SUPSI is a leading institution in Switzerland, active since many years in the field of photovoltaics, and in particular on building integrated photovoltaics. We have our first project launched in 1997 with the conventional PV modules. And from that time, thanks to the support of different European and international projects, we have completed different pilot and demonstration projects using innovative solution for the different type of the envelope. From 2010, we are also managing two platforms, digital platform. One is the BIPV.ch and the other one is Solar Architecture. So just to give you an idea on BIPV, first of all, it's important to understand the definition of BIPV. And here you see, oh, you can go to the next, please. Good, thanks. So first of all, the definition of BIPV. Here you can see the definition of the IEC63092 and from the European one, the 5583, that was developed also within the IEA task. So photovoltaic modules are considered to be building integrated if the PV module form a construction product, providing a function as defined in the construction product regulation. Those, if you have to replace the BIPV component from a building, you have to substitute it with another component with the same building functionality. Please go to the next. So the potential of BIPV is very large, but from the literature, there are not so clear number on the exact potential of BIPV. From what you can see here, this is the historical evolution of BIPV market in Europe. And you can see that we have a peak in the European market about 10 years ago, when this is mainly due to the implementation of specific feed-in tariff in place in different EU countries. We have calculated that in Switzerland, the facade potential of BIPV is about 17 terawatt-hour a year, about 1/4 of the Swiss electricity production. And to this, we can add also 50 terawatt-hour that can be produced by a rooftop integrated PV. Please, next. So the market is very diversified, variegated, that make the things very complex for BIPV. And here, within a project together with a colleague from INEA, we have diversified the market in 4 categories. We can go from the MyPV roof approach, where I can use standard crystalline or high efficient PV module on top of my roof, toward the net zero energy buildings approach, where PV has to be really integrated into the PV systems of the buildings. And in between, we have a large market that deal also with the renovation of existing buildings, where people and building owner are looking for high aesthetics solution to be integrated into the building skins. So please go to the next. A recent study of the IEA Task 15 categorized the different opportunity for BIPV. For all of these possibility, when we want to speak about high value solution, integrating next generation PV technology such as perovskite, I see a great opportunity in commercial buildings, where facade and external integrated shading devices, for example, such as Venetian blind or carpet, can play an incredible role in achieving net zero energy building or zero carbon buildings. Often, these buildings have large glazing area that should be also protected to prevent overheating, or solutions that need to be flexible in terms of design and geometry. Moreover, in large cities where the rooftop area is a small fraction, there is a major resource of solar energy falling on the facade. This is the next. If you go to the next slide, please. Thanks. To give you some number, today there are more than 5,000 multi-story and highly glazed buildings under construction or proposed worldwide. The major role is in Asia, especially in China. That is the highest market for BIPV and for glazing skyscraper. But also North America play key roles in this sector. Please go to the next. A very important topic is the price range and the cost competitiveness of BIPV in comparison to conventional building products. And here you can see a research study we did. You can see that for conventional roof solution without PV, The price can range from about 0.025 euros or dollar per square meter up to $400 per square meter. While if you go to the facades, the range is even larger and can go towards 1,000 euro per square meter or even more if more or very sophisticated high-value solutions are used. An approach is to consider the extra cost of BIPV element in order to calculate the cost effectiveness and return of investment of BIPV solution. Please go to the next. To conclude and summarize the challenges and opportunities when developing new perovskite solution for the building market, I encourage to consider the following. BIPV has to face articulate buildings that are normally in urban dense environment where also vegetation is present, and architect and facade engineers need to work not only with glass solution, but also other materials such as ceramic, aluminum, concrete, or fiber cement. Can you click again? Therefore, if you go to the click again, please. So therefore, next generation BIPV solution, including perovskite, should consider the possibility of different geometries and shapes, capability to resist against shadows, ability to be incorporated and coupled with different material than glass. Colorness also is very important, and also it's mandatory to consider normative and topic of circular economy. Please go to the next. So how to win this game? It's important to further invest in a flexible and automation production line to be able to offer to the market a wide range of products that are also cost competitive in comparison to conventional building elements. And standardization has to be improved, and digitalization and digital process can support and enhance the collaboration through the value chain of construction. If you go to the next, I would like to thank you for your attention. And if you want to learn more about the status of BIPV, I encourage you to have a look on our last BIPV status report on BIPV. Thank you very much, and sorry for these technical issues.
Thank you, Professor Dr. Frontini. We will move into the next. Mr. Nguyen Tien, Power Leader, Power Department, Thang Industrial Park, Vinh Phuc Corporation. So Mr. Nguyen, if you please.
Good afternoon, everyone. My name is Nguyen Tien, Leader Power Department of Thang Industrial Park, Vinh Phuc Corporation. Hereafter, I will call it TLIP. As you can see on my screen, the topic today is a potential of perovskite in our industrial park. First of all, I would like to give you an overview of our industrial park. Sumitomo Corporation is owner and operates 8 industrial parks in 6 countries, and mainly in Southeast Asia, include 3 industrial parks in Vietnam. Overview about TLIP in Vietnam. TLIP number 1 was established in 1997, and TLIP number 2 was established in 2006, and TLIP number 3 was established in 2015, with over 200 tenants, and according to our experiment, building and operating the industrial park over many years, we offering the best quality of infrastructure and service. I would like to go to the next point about recent investment trend in TLIP. We have been trying to match the needs with 234 tenants and with 25-year operation with 100,000 employees. Recently we have various type tenants. For example, they building the second factories to expand in Vietnam. And recently, the Vietnamese company also entered into our industrial park, attracted by our value infrastructure. Even though we correspond almost 90% Japanese tenant in our industrial park. I would like to describe about rooftop solar project in TOIP. Since February 2021, we start the pilot project, and after 3 years, we installed 21 projects on the rooftop of tenant, with total capacity until now is 37 megawatt peak. And based on the annual consumption volume in TIP, we export 1,000 gigawatt hour. We are achieving 100 megawatts by 2030. And the business mode of rooftop solar will be spread out to our nature park as in other countries such as Bangladesh. I would like to present quick about our configuration rooftop solar projects for in TIP. Our system will supply power directly to tenant factory. TIP facility includes the PV panel, inverter, water pipeline, tank pump for cleaning, and the system will connect directly with the electrical panel of tenant at the low voltage side of transformer. And the tenant will consume directly the power from the system. I would like to go to highlight session today about the potential of perovskite in our industrial park. First reason, in last summer in Vietnam, we suffered from power shortage issue due to some hydropower plant lack water for generate power. Expected in next summer, major problem may happen again in Vietnam. So the Vietnamese government encourages renewable energies. They would like to increase from 25% in 2020 and go up to 68% in 2050. From our, also they have intention to promote thing of self consumption type of rooftop solar, expected to increase by 2,600 megawatts until 2030. From our side, to minimize the impact of power shortage issue to our tenant, we also need to ensure power for production activity of tenant. So install the rooftop solar is one kind of our solution. And second reason, during the implementation of rooftop solar, we encountered that a problem that the tenant were building the factory 10 to 20 years ago. And at that time, they did not consider to install solar on the roof. So then when we check the roof condition, the roof not qualified to install the solar power on the roof with the weight of silicon panel around 11 kilograms per square meter, and can we go up to 50 kilograms per square meter after install the laser mounting structure and cleaning system. Therefore, the perovskite solar cell with lighter weight and high efficiency is one of the potential solution for the factory with the loss capacity. And the third reason, as you can see on the screen, as the data on the website Global Solar, our solar radiation in our energy park, I made a sample in TIP number 3, is only 664 kilowatt hour per square meter per year. This index is lower than compared with southwest Vietnam, like such as the Ninh Thuận province, which have high radiation up to 1,800 kilowatt hour per square meter. And look at the charts. the perovskite now can go up to over 25% of efficiency, compared with the current silicon solar panel we are using is around 20.9%. This is extremely promising. Therefore, finding solar panel with higher efficiency is an issue we are very interested in. I would like to thank you for listening. Thank you.
Mr. Nguyen, thank you for your presentation. Following the presentation, we will have a panel discussion on carbon neutral city achieved by next generation photovoltaics, and Professor Takamura will act as the moderator. All the panelists, please go up to the stage.
So now we turn to the panel discussion. So I personally very much enjoy each presentation by panelists. So as all know that today's focus is the next generation PV, perovskite PV, and which actually they have quite the strength and the potential to the challenge that we face toward decarbonization, not actually responded sufficiently by the conventional PV, maybe the beyond rooftop installation. So maybe the East and the Southeast Asia, including Japan, in some country has very much limited land areas, so that with the very high population density and highly developed city or emerging cities. So in order to achieve the global carbon neutrality, definitely we need to expand the green electricity, green power from the renewable sources in each country and region. Actually, new renewable energy sources such as the perovskite PV will be very much expected to play a greater role towards carbon neutrality. In addition, as you know, that the energy supply risk has, been apparent. It's become a reality due to the Ukraine crisis. We believe that the expanding domestic and local energy production source from the renewable sources may definitely contribute to enforce or enhance the energy security in the country, such as the country depending on the imported fossil fuels. So with such situation, in my presentation, I already pointed out that the social deployment, implementation of the perovskite PV are necessary for our challenge toward the carbon neutrality. Also, Mr. Yamazaki introduced a Green Innovation Fund and project, deployment under this GI, Green Investment Fund in Japan, and Dr. BESSHO and Dr. YAMAMOTO in their presentation of each introduced their history and the status of the development of the new generation PV, and also their business strategy in its manufacturing. So Professor Frontini, by online, kindly introduced the possibility of, I understand, the building integrated PV application and its challenges. And lastly, not least, but Mr. Nguyen introduced a need of perovskite PV from the perspective of demand side. So based on these presentation, I prepared two sets of questions. First question is how to promote further or how to further expand the dissemination of the green power sources and the green power from the renewable? That is first question. And the second question is how to cooperate internationally, maybe across the industry sector. That is the second question. So then I'd like to now invite to ask each speaker or panelist to respond to my first set of questions. So I now turn to the Yamasaki-san for two maybe sub-questions. First question is that you emphasize that cost reduction is quite essential for this expanding the green power, such as perovskite PV, new generation PV. But do you think that what are challenge to achieve this cost target especially? That is the first question. The second question is that what kind of innovation is needed to expand the deployment in the reality of the new generation PV? Thank you.
So thank you for Takamura-san. About first question regarding cost reduction of the perovskite module. In this time, R&D stage of the perovskite, as Yamamoto-san has mentioned about cost reduction. So I also think about it might be several factors to the cost reduction. So it will be needed. Not only efficiency module. So important is efficiency module, and also processing cost to make module. But also, there are so many factors. So system cost, including power conditioner and construction cost and lifetime. I think lifetime is important because silicon photovoltaics have a long time, over 20 years. Perovskite is one of the key challenge is reliability to need some lifetime in the future. So second question about to make innovation for the social implementation. So social implementation in the urban area to deployment. So perovskite photovoltaic deployment in urban area, I think important. So many stakeholders should be involved. So besides PV manufacturing company, such as Sekisui Chemical and Kaneka, and also I think architecture, design office, construction company, and estate company, university, and also local municipality, and also BIPV specialist. So to introduce new type module, such as perovskite, is one of the big challenge. So it might be a little different of the silicon module. So to collaborate, so many stakeholders, I think it is important.
Thank you very much. Kind cooperation to your comment to be believed. Again, the request others panelists as well to do your effort to your comment as brief as possible. I think that's the good reason to receive the all comment from you. So now I turn to the BESSHO-san because now the Yamasaki-san mentioned that how to reduce the cost, especially not only the cost efficiency of module, but also this system cost, and the durability are also in question. So I'd like to then the BESSHO-san for three questions. what approach do your company take to reduce manufacturing cost and improve durability? The second is maybe what's your company's business and investment plan for further deployment? The last third question is that I understand that the Sekisui Chemical has the group company, as house building companies. So, is there any the request for the product specification or characteristic for the perovskite photovoltaic, especially the housing market request? Yeah.
Okay. So, Professor Takamura, thank you very much for your questions. So I will answer the question, and I hope it's a fit for you. Yes. So first, I want to talk about the cost. So as I explained in my presentation, the cost of a production might be reduced by a roll-to-roll process. We are thinking about it. So now I think the weight or a power per time, a minutes, in a production line is very important for reducing the cost of production of the devices of perovskite. So roll-to-roll process, it's not easy to make devices like photovoltaic devices, but we can maybe increase the module a square meter per time. That's why we are concentrated on development of a process, how to make the devices by roll-to-roll, everything a roll-to-roll process. So this is our challenging of the technology development, but fortunately we managed. And of course, in the future, we also more manage about processes and increasing cost reduction, and also power consumption of devices in the future. So we believe that we can do it, and we can reduce the cost of devices more in the future soon. And then, so second point is also durability. So durability is almost the most a key point of perovskite materials, also devices. And normally a perovskite is very weak for the water and also, of course, humidity and oxygen, and also light and temperature. So now we can prevent the water and also oxygen by a sealing process and the sealing materials and sealing technology. So we focus on this kind of technology development by ourselves with using our chemical nourishment, and we managed first for the durability of 10 years now with IEC61215 test, and I think this is the first and only technology in the world for Sekisui Chemical Company. This is our main point. And we are thinking about getting more good technology, improvement technology to get more than 20 years durability. As Yamazaki-san said, this is a target as well. So second, so this is a plan of our company. Actually, we cannot tell the details, but now we are thinking about 0.1 gigawatt scale of device production of perovskite devices. Of course, if it's possible, we want to go more. But first, we need to think about cost 40 yen per kilowatt hour, and with a 0.1 gigawatt. So third one. So actually, we also have a good collaborator as a house maker in a Sekisui Chemical Company, so Sekisui House. And we have tested several devices on the rooftop of houses and also walls and several places with our devices. And people said people has already knowledge and the technology how to put silicon solar cell devices a lot already, and it's solid and also it's a little bit heavy, and they didn't have any knowledge about this kind of a very light, flexible type of devices on the rooftop. So now they have a new problems to think about how to fix this kind of very light devices on the rooftop, because in Japan we have a typhoon on summer season, and the wind is very, very strong. And this kind of devices can be fixed on the rooftop, but people doesn't have this kind of technology. So now we are trying to be solve this kind of problem by together with companies of Sekisui House together. So thank you very much.
Thank you very much comprehensive comment and answer. I'm looking at the time. I think we have still the 3 panelists for the first set of questions. So that please your comment brief as much as possible, I hope. So the next it will be say the Yamamoto-san from Kaneka Corporation, and I quite a similar question to the BESSHO-san. But first question is that what is your approach to reduce manufacturing cost and improve durability? And the second is what's your company's business investment plan for future? And then maybe you can have what kind of new market use. What is your perspective on this point, please?
I believe I have already mentioned during my presentation. Kaneka is now doing a business by using a silicon. So first of all, I have to say that durability, namely reliability, is most important. At least 20 years more is needed. If not, no way to go into the business. So we call reliability, durability, and stability of a module is very important. So our approach is first, and we would like to use glass lamination with good seal, like PIB seal, and also the increase in stability of that perovskite itself against heat and light. We have been intensively working on additive for producing that perovskite itself. And then, as I mentioned in my presentation, efficiency, modular efficiency is really important for reducing the system cost, or definitely that manufacturing cost. And also, we want to use a robustic technology, fully integrated technology. Glass in, module out. Module means already measured and also wiring and everything completed. So for the starting the manufacturing, we have to overcome this issue. So we want to start as early as possible, but we would say that something like the late 2020s, we want to start the manufacturing. This is a plan. Of course, if we have resolved this issue as early as possible. Another, that is application. We now, even in silicon, we are very much focused on quite a niche market, the roof-tile integration, and also the building integration by using the solid type and also see-through type. So we want to, if we got a very high efficiency, like 30% by perovskite silicon tandem, new approach. Of course, we are working on roof of the mobility that might be the higher efficiency will be replaced, and even the building on the top, high efficiency is a really key impact. So we have a chance to open the new world, especially see-through. Thin film is very good at doing that, and with especially urban building, as working with Taisei Corporation, we have by adding the perovskite module, we opened a new opportunity for the building owner, and also the designer of the architect of the building. Thank you.
Thank you, Yamamoto-san. I think the both company, BESSHO-san and Yamamoto-san, really emphasize that how to reduce the system cost, and of course maybe they may be a little bit slightly different approaches, but that is quite important. And second point that I think they commonly shared between two panelists is that the collaboration across the industrial sectors, I mean the business sectors, that is, I think, the key for the expansion of these technologies. So now I'd like to invite Professor Frontini. I have two questions to you. First question is that do you see what kind of requests and needs that the building owner and developer wish to have, especially regarding the silicon type BIPV? That is my first question. And the second question is and then what's the challenge to respond to such need, market need, and the building owners and developer need in order to be successful in the BIPV market? So you have the floor, Professor Frontini.
Thank you. Thank you very much for the two questions. And indeed, I was also very interested to learn what the previous speaker already presented. So regarding a building owner and developer, I believe that first of all, aesthetics is a priority, meaning that BIPV should seamlessly integrate into the building design and architecture. So normally, building owner requests visually appealing solar panels, such as those with various color options, transparency, different pattern to match the building aesthetics and also the design requirement. So if the PV module is not able to answer this architectural requirement, it's very difficult that the market will adopt them or that will be implemented in real project. So if you think about crystalline silicon PV, BIPV modules, the conventional one, they're normally used for back ventilated facades like cold facade or roofs in an opaque system, and seldom in semi-transparent application. And we saw from Kaneka, for example, what is now possible with perovskite, to have this kind of semi-transparent solution that are much better for the transparent part of the building envelope. Moreover, I think that the second point that was also addressed by the colleagues before is durability. So durability is really one of the major concerns of building owners and developer, since BIPV and perovskite has to compete with conventional building products or conventional PV panel that where the lifespan is quite long, between 20 to 40 years. Therefore, it's really important to have this kind of offer from also BIPV and perovskite solution. There is also a niche market, like for example, the one of PV shades or curtain, where even less durable solution can be adopted, but always in the range of 10 to 15 years, more or less. So I would encourage you to have a look on what we have recently reported within the IEA PVPS Task 15, where we compile and analyze user needs for BIPV and in their different functions. Coming to the second question regarding challenges and for manufacturer, I mean, they're pretty similar to the one of the building owner, but they are seen from a different perspective. So I think that what BIPV manufacturer has to address is to be able to offer to the market a wide range of palette of solution. Because as we also seen from previous examples, there are not buildings are completely different. So every building is has its own shapes, form, color, transparency, or not. Therefore, it's important that with new technology we are able to address this multifunctionality and these different requests from the design perspective. Moreover, it's always important to invest in efficiency and performance. So this is also a key point. we are targeting zero energy or zero carbon buildings. Therefore, we need solutions that are able to cover the most of the energy needs from our building sector and from our society. And this can be done only if we can really improve efficiency of solar cells. And then we need also to further harmonize or work together in order to provide also the right standardization framework where the path and the requirement are very clear also from the module manufacturer. So today it's not very clear the situation, and we have quite different also rules in different countries and different regions. And to conclude, I think another point it's very important, and is that manufacturer needs to really educate the market also on the possibility they are offering. So they have to increase the awareness of architects, developer, new generation, new young students about the benefit of BIPV and the implementation of renewable energy in our buildings. I think I've answered most of your questions.
Yes, perfectly. Thank you very much. Very much impressed by the importance of aesthetic aspect and design, and also the very impressive word and educate market. That is very much the insightful comment. Thank you very much. So now I turn to the Mr. Nguyen. I focus 2 questions. So the first question is that you said that there is some kind of power shortage in Vietnam, and the motivation that you introduce this the green power supply is that rather ensure the power supply capacity, or at the same time green power supply, which is the most important? That is the first question. The second question is that you also mentioned that load capacity requirement from the government is one of the challenges. Is there any issue or any condition, for instance, the durability or efficiency, in addition to load condition requirement?
Thank you, Takamura-san. I would like to answer your question. First question. For tenant, the power supply is mandatory to continue the production, which is a priority than anything. So we need to keep enough power for production activity of tenant. The decarbonization is one of the elements that the tenant need to achieve. But in the current state, not all tenants require the decarbonization. It's actually manufacture and supply for big techs like Apple or Amazon, automotive, are very aggressive to target the activity in our industrial park. And then the second question about the challenges of projects. Just the load capacity is the basic component of this business scheme. No matter how much the efficiency it goes, and addition is wonderful, the load capacity of the factory should be enough to install the rooftop solar. Of course, that an investor point of view, we are willing to the PV panel with a good efficiency and good adhesion. However, in the current situation, we have so many factories who give up installing the solar system due to the lack of load capacity. Yeah.
Thank you, Mr. Nguyen. I think that they show what's the motivation and what is the request and the wish for the new generation PV. Thank you very much. So, due to time constraint, I think the second set of questions is the little bit focus answer is requested. So my secretariat asked me 30 seconds, but it's maybe too short, but try to be brief within the hopefully 1 minute. So I expect that the Yamazaki-san wrap up, so that I'd like now the BESSHO-san to respond. What's the international collaboration possible to expand this, the new generation PV? So please.
Thank you very much. So now we are thinking of, we need to think about like a regulation on each countries. And the house situation and the building situation, each country is totally different. In Japan, in Asia, in Europe, in America, they have their own like regulation. And when we think, when we try to put our very flexible devices on places, we really need to consider under discussion on each country's specialty of technology persons and also regulation persons and the government person together. So we need good collaboration. And if it's possible, government kindly can introduce this kind of like a special person to us. Thank you very much.
Thank you very much. So now I turn to Yamamoto-san, please.
So from my point of view, anyway, reliability is very important. So of course, kind of industrial collaboration also important, but still perovskite has a huge potential. So we need still global collaboration to realize a good enough reliability of a perovskite module. So lots of research has been going on, especially in Europe. Very nice research has already published. So from the European Institute or university. So I think still such kind of fundamental point of view also I believe is important.
Excuse me. Thank you, Yamamoto-san. And then now I'd like to invite Professor Frontini. What do you think that the international collaboration is possible and necessary and have potential? So please, brief. I'm sorry, 30 seconds.
No problem, yes. So I think it's also very, very important to encourage collaborative research projects between institution, university, and private sector. So this is also what our university is trying to do, but also to support networks such as the IEA PTPS program and many other, trying to really offer the possibility among the different institutions and the industry to collaborate, because we need, as was mentioned before, a more clear international standardization framework and certification, so that we can really push forward the implementation of this new technology. One of the way we are doing is also to develop internationally wise guidelines to support industries, but also planners to further use this technology.
Thank you very much. So now I turn to Mr. Nguyen. What is the possible international collaboration to expand this next generation PV?
Thank you. From my point of view, now Japan is a leading country to research and develop the perovskite. So in case the Japanese government can cooperate with some country like the Vietnam to establish the research center and, for example, make the pilot projects. In this case, if have opportunity, we can join the pilot project to install the perovskite on the roof of tenant with like a large capacity in our nature park.
Thank you. I see a lot of potential for the collaboration between two countries. Thank you very much. So, last not least, but Yamazaki-san, could you please wrap up?
So thank you so much. So many the keyword in this discussion. So such as guideline, regulation, standardization, and the pilot project. So there are so many potential international collaboration. I think so, but so perovskite R&D is is so many company conduct R&D, so to select a collaborative area and a competitive area. So this keyword, and to select to hear the need the company. So Japanese government and NEDO, and also to select this field. And so such kind of guideline, standardization, and also, so I think important the measurement. So international collaboration, the measurement is so such kind of reliability is important. I think so. In this Green Innovation Fund project involved by AIST and many universities in Japan. So such kind of laboratory and university might be this kind of collaboration.
Thank you very much. Unfortunately, I'm sorry to say that due to my really, I couldn't receive the question from the floor, but maybe you can approach to each panelist after this session. So as the Yamasaki-san already wrapped up, I think this new generation PV has a great potential, but a need. They very much in collaboration, of course, at the international level, but also even across the industry sectors. I think this Green Innovation Fund project, I think that is, I hope that it's become a model for such kind of initiative or the expansion of the new generation PV. So with that comment, I close this session. Thank you very much for the panelists. Please join me to give applause to the panelists, please.